Hello students, today's first question is, during a certain bicycle ride, was Sherry's average speed faster than 24 kilometers per hour? So we have to find that Sherry's speed was whether greater than 24 kilometers per hour or not. Fine. Now, in bracket we have been given the conversion 1 kilometer is equal to 1000 meters. Moving to statement 1. Statement 1 says Sherry's average speed during the bicycle ride was faster than 7 meters. So let us suppose Sherry's speed is S. So S is greater than 7 meters per second. Now here we need to convert meter per second to kilometer per hour. Right? Now, whenever you are asked to convert meter per second into kilometer per hour, so you need to multiply it by 18 by 5. Right? Whatever has been given in meter per second, you need to multiply that with 18 by 5 to get that speed in kilometer per hour. Or if you want kilometer per hour to change into meter per second, for that the conversion is 5 by 18. You need to multiply anything with kilometer per hour by 5 by 18, you will get that in meter per second. Now here basically this is a question of unit conversion. So speed is greater than 7 meter per second. So since this is 7 meter per second, I will multiply it by 18 by 5. So to get it into kilometer per hour, by multiplying I get the value 25.2 kilometers per hour. Now the question has been asked that whether the speed is greater than 24 km, and the statement 1 says that the speed is greater than, was faster than means 25.2 km per hour. Sherry's speed was greater than this. So we can surely say that the speed was greater than 24 km per hour. So statement A is sufficient to answer this question. Now moving to statement 2. Statement 2 says Sherry's average speed during the bicycle ride was slower than, so S is less than 8 meters per second. Right? So again multiplying 8 by 18 by 5. So what we get? So this comes out to be 28.8 kilometer per hour. So this says that speed is less than 28.8 kilometer per hour. But can this solve our question that whether the speed was greater than 24 kilometer per hour? No. Why? Because S can take the value 27 kilometer per hour, or S can take 20 kilometer per hour. Right? So for this we can say that Sherry's speed was yes greater than this, and for this we can say no, because it is only given that it is less than this. In the first case it was given greater than this. So greater than this, since 25.2 km per hour is greater than this, any value greater than this will obviously be greater than this. So statement A surely tells us that the speed is greater than 24 km per hour. But statement 2 doesn't tell us this. So statement B is not sufficient. For this the answer is statement A is alone is sufficient to answer the question. Working together, Rafael and Salvador can tabulate a certain set of data in 2 hours. In how many hours can Rafael tabulate the data working alone? Right? So let us suppose Rafael alone takes R hours to complete the work, right? And Salvador takes S hours to complete the work, right? Now it has been given that together they complete the work in 2 hours. So 1 by R will be the efficiency in 1 hour for R, and 1 by S will be efficiency of Salvador in 1 hour. Right? Now, we can take examples. Let us suppose that R takes 4 hours to complete work. Right? So 1 by 4 is the job done in 1 hour. So they take 2 hours. So multiplying it by 2 should be equal to the total work, which is 1 unit. Right? So this is what is given from the main statement. Now we need to find R. Now statement 1 is working alone. Rafael can tabulate the data in 3 hours less time than Salvador working alone can tabulate the data. So we have been given the comparison between R and S. Now since here R and S denote the number of hours taken by Rafael and Salvador, and it has been given that Rafael can tabulate the data in 3 hours less time than Salvador. So in order to equate, I will write R plus 3 equal to S, because R takes 3 hours less, so adding 3 to it will be equal to the time taken by Salvador. Right? Now putting this value over, since we need to find R, we will substitute S with R. So this becomes 1 by R plus 1 upon R plus 3 multiplied by 2 equal to 1. Now this is a single variable equation R. So this becomes LCM is R into R plus 3. In numerator we will be having R plus 3 plus R multiplied by 2 equal to 1. Now this further implies 2R plus 3 multiplied by 2. In denominator we will be having R square plus 3R equal to 1. This further implies 2 to 4R plus 6 equal to R square plus 3R. Now since R square is positive over here, we will try to shift all these values over here. So this becomes R square plus 3R minus 4R minus 6 equal to 0. So this becomes r square minus r minus 6 equal to 0. Now this is the equation, quadratic equation. Now splitting the middle term, we need the product to be equal to minus 6 and sum equal to minus 1. So this will be written, this can be written as r square minus 3r plus 2r minus 6 equal to 0. Taking r common, it will be r. So here minus 3 r plus 2r becomes minus r, and minus 3 into minus 2 is minus 6. So taking r common, I will be having r minus 3 plus taking 2 common, r minus 3 equal to 0. So this further implies taking r minus 3 common, I will be left with r plus 2 equal to 0. So from here I can find the value r is equal to 3 and r is equal to minus 2. So minus 2 can't be the number of r, so it has to be positive. So this is, so we get the value for number of r's. R takes alone to complete the work is 3 hours. So we can say that the statement A is sufficient to answer this question. Fine. Now moving to statement 2. So statement 2 tells us that working alone, Rafael can tabulate the data in 1 by 2 the time that Salvador working alone can tabulate the data. So this means that R is equal to 1 by 2 of S. Fine. Now this is the main equation which we have calculated. So putting the value of S equal to, this implies S is equal to twice R. So I'll put that value over here. So this becomes 1 by R plus 1 upon 2R multiplied by 2 equal to 1. So taking LCM, I will be getting 2R square. In the numerator, I will be getting 2R plus R multiplied by 2 equal to 1. So this implies 3R multiplied by 2 equal to 2R square. Now 2 and 2 gets cancelled, R and R gets cancelled, and I am left with R equal to 3. So this statement also gives us independently the value of R, which is the number of hours taken by Rafael to do the tabulate the data alone. So we can say that statement B alone is also sufficient to answer our question. So right option for this question will be option number D. So since both the statements individually are sufficient, so we'll mark the option D as the right answer. If x and y are integers, what is the value of x? So we have been simply given that x and y are integers and we need to find the value of x. Now moving to statement 1. Statement 1 tells us that x into y is equal to 1. Now since both are integers, so either we can have two possibilities. Since the product is 1, either x is minus 1, y is minus 1, so the product becomes 1, or x is 1, y is 1, so in that case also the product will be 1. So we are getting two values of x, minus 1 and 1. Right? So we can say that statement A is not sufficient to answer this question or give us a discrete single value of x. Now moving to statement 2. Statement 2 tells us independently that x is not equal to minus 1. Now if x and y are integers and x is not equal to minus 1, so it can be any other integer. It can be 1, it can be 2, it can be minus 4, it can be minus 6. So still we are not able to find the single value of x. So statement B is also not sufficient. So this means that statement D, that individually both statements are sufficient, is also not the option. Now we are left with option C and D. Now C says combining statement 1 and 2. So statement 1 tells us that xy is equal to 1 and we have found two possibilities, and from statement 2 we get that x is not equal to minus 1. So which tells us that x has to be 1 in order to have the product 1. So in this case 1 into 1 is 1. So we can say now that x is equal to 1, because from the statement 1 combining both statements we get that the product is equal to 1 and x is not equal to minus 1. So the possibility arises is this one, only this one. So x is having the value 1. So we can say that for this both the statements together are sufficient to answer this question. The figure above shows line L, circle 1 with center at C1. Right? So this is a line L. And this is a circle with center at C1 and circle 2 with center at C2. Line L intersects circle 1 at points A and B. Line L intersects circle 2 at points D and E. And points C1 and C2 are equidistant from line L. So that means that this distance from C1 to this line and C2 to this line are equal. Is the area of triangle ABC1 less than the area of triangle DEC2? Now we'll first draw the. So if we join C1A and C1B, we will be getting a triangle like this. So this is C1, this is A, and this is B. And we have been given that this distance is equal. So we can mark this H, this as D. So C1D is equal to, now for this triangle C2, we draw another triangle. So this is C2. This is the portion, D is and AB is the portion of line L. So we have been given that this is also C2, ABCDE. C2E is equal to C1D equal to H. So this has been given in the main statement. Right? Now we need to find that is the area of triangle ABC1 less than the area of triangle DEC2. Right? Now, from this we can calculate that since this is an altitude, so area of triangle ABC1 will be equal to 1 by 2 into AB into H. Is this less than 1 by 2 DC into H? Now 1 by 2 gets cancelled, H and H gets cancelled. So we need to find whether AB is less than DC. We simply need to find this. Now with this information, moving to statement 1. Now, statement 1 tells us that the radius of circle 1 is less than the radius of circle 2. So these are the radius, right? C1A and C1B, these are the radius. So let us suppose the radius of this is R and this is R1. So from statement 1 we get that R is less than R1. Right? Now from this we can logically deduce that since R is less than 1 and height of both the triangles are same, so this means that AB has to be less than DC, because let us suppose we draw two circles, one is this and one is a bigger circle. Right? Now from this, if there are, and from here, since this height is same, this is same for both, and this radius is R and this is R1, right? So R is less than R1, so that means this side will be, since heights are same, so this AB has to be less than DE, and this DC, sorry, here it is DE, this is DE, so this will be DF, right? So this we can logically deduce from here that AB is less than DE. So this solves our purpose that the area of triangle, this we can concretely say that this is sure, yes. So we can say that statement A is sufficient to answer our question. Now moving to second statement. Second statement says us the length of chord AB is less than the length of chord DE. So this is what we needed to find, that length of chord AB is less than DE. So this is what statement 2 says. So we can say that statement 2 is also sufficient to answer this question. So the right option for this will be option D, that both the statements individually are sufficient to answer this question. If you have some confusion over here, that since R is less than R1, since height is same, so from this figure you can come to know that AB has to be less than DE. So statement 1 is also sufficient to answer this question. So right option for this would be option number D. Both statements alone are sufficient to answer the question. Yesterday between 9 a.m. and 6 p.m. at airport X, all flights to Atlanta departed at equally spaced times, and all flights to New York City departed at equally spaced times. A flight to Atlanta and a flight to New York City both departed from airport X at 1 p.m. yesterday. So he says that from airport X at 1 p.m. flight departed to both New York City and to Atlanta. Between 1 p.m. and 3 p.m. yesterday, did another pair of flights to these two cities depart from airport X at the same time? So we need to find that between 1 to 3 p.m. did both flights fly at the same time. So we need to find whether this has happened or not. Moving to statement 1. Statement 1 says, yesterday at airport X, a flight to Atlanta and a flight to New York City both departed at 10 a.m. So this says basically that from airport X at 10 a.m. flight departed to both New York City and to Atlanta. But this just doesn't give us any information about, yes, that between 1 to 3 p.m. did any flight, both the flights fly at the same time. So statement 1 is not sufficient to answer our question. Now moving to statement 2. Statement 2 says that yesterday at airport X, flight to New York City. So it tells us that from airport X, flight to New York City departed every 15 minutes between 9 a.m. and 6 p.m. So this basically tells us that after this 9:15, then 9:30, then 9:45. So it tells only about the flight to New York City, but it doesn't tell anything about flight to Atlanta City, so that we could calculate that after this that would be 10 o'clock. Right? So between 1 to 3 p.m. we can calculate from this trend about the flight to New York City, but we don't know any information about Atlanta City. So option B is also, statement 2 is also not sufficient. So this means statement D is also not sufficient. Now we will look for statement C. Statement C, combining first and two statements. First says that the flight departed at the same time at 10 a.m. and second says that it continuously departed after 5 minutes, the flight to New York City. But still we are not having the trend of flight to Atlanta City. So we can say that statement C is also not sufficient, and in this case we will mark the option E, that both the statements are not sufficient to answer this question. Of the total number of copies of magazine X sold last week, 40% were sold at full price. What was the total number of copies of the magazine sold last week? So we need to find the total number of copies, out of which 40% were sold at full price. Now let us suppose the total number of copies sold be n. So copies sold at full price were 40% of n, so that will be 0.40 into n. Right? Now what was the total number of, so we need to find basically n, and there is one more thing. What was the other total sold at 40% were sold at full price? So let us suppose that full price be equal to p dollars. Right? Now moving to statement 1 with this information. Statement 1 says that last week full price for a copy of magazine X was $1.50. So that means we have been given the value of P to be $1.50. The full price was $1.50 and the total revenue from full price sales was $112,500. So that means basically that 0.4 into n multiplied by 1.5 is equal to 112,500. Because n is the total number of copies and 40% were sold at full price, and full price is 1.50, and it says that the total revenue from full price sales, so full price sales is equal to this. So from this we can calculate n, so that will be equal to 112,500 divided by 0.4 into 1.5. So from here we come to know that this is a single variable equation, so we can simply mark that statement A is sufficient to answer the question. But for the sake of the question we will solve this. So this comes out to be 187,500 unit and 1,87,500 copies were the total copies. So statement A is sufficient. Now moving to statement 2. Statement 2 says that the total number of copies of magazine X sold last week at full price was 75,000. So what does that mean? That means that 0.4 n was equal to 75,000. The total number of magazines X sold last week at full price. So dollar should be omitted from here. So this is the number. So from here I can calculate n, 75,000 divided by 0.4. So statement B is also sufficient to answer this question. So this also comes out to be 187,500. So for this question, statement D, that both the statements alone are sufficient to answer this question, is the right answer. You have to omit this dollar over here because this is the total number of copies of magazine X sold last week at full price was. So this is a number. If P, S and T are positive, so we have been given that P, S and T are positive. We need to find is mod of PS minus PT is greater than P into S minus T. Right? Now first we'll try to solve the left hand side. So taking P common, so I will be having P S minus T mod. Since P, S and T are positive, so P can come outside. So this can be P into S minus T mod is greater than P into S minus T. So since P is positive, so it can be cancelled out. So basically we need to find that is mod of S minus T greater than S minus T. Now two cases arise. First is if S minus T is greater than or equal to 0. So in that case this will be equal to this. Right? Now the second case is when S minus T is less than 0. So this portion will become negative, and this being negative taken care by mod is it will be positive. So S minus T mod will be positive. So basically we need to find that whether S minus T is less than 0 or S is less than T. So the question boils down to the fact that whether S is less than T or not. Now moving to statement 1. Statement 1 tells us that P is less than S. Now if P is less than S, then we can take some values for this. So there has been no relation between S and T. No relation has been given in statement 1 regarding S and T. Right? Now let us suppose P is equal to 5, right? And S is equal to 10 and T equal to 15. So this is an example. Now P is less than S and S is less than T. But if P is equal to 5, S is 10 and T is 3. In that case P is less than S, right? Because we have to follow this rule. But S is greater than T. So this possibility, both the possibilities can arise from here. S is greater than T and S is less than T. So we can say that statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 says that S is less than T. So this is what we needed to find, that S is S less than T. So that in that case, or we can say that S minus T is less than 0. Right? So we can say that statement B is sufficient to answer our question. So right option for this question will be option number B. Let's dive some deeper into the fact that C, we have been given that mod of ps minus pt is greater than ps minus t. We need to find whether this is true or not. Since p is positive, we can cancel out from both sides. So we are left with s minus t mod greater than s minus t, right? But if s minus t, so let us suppose this can happen only when s is greater than t, right? So if s is greater than t, so right side will be positive, right? And left side will also be positive, right? Now if s is less than t, then this part will be negative, but this part will also negative, but taken care by mod it will be positive. So we can say that s minus t mod is greater than s minus t. So that's why we need to find whether s minus t is less than 0 or not, right? So basically we need to find s less than t. So that has been simply provided by the statement 2. Whenever a mod comes, so we can have two options. One is s minus t, and one is minus of s minus t. So we need to take care of both the options. Is x greater than y? So we have not been given anything else about x and y. So we need to find is x greater than y, right? Now moving to statement 1. Statement 1 tells us that x plus y is greater than x minus y, right? Now we will assume some values for this to identify. Let us suppose x is equal to 2 and y is equal to 1. So in this case 2 plus 1 is greater than 2 minus 1, so 3 is greater than 1. So we can say that yes, x is greater than y, right? Yes. Now let us take some other values for x and y. So if x is equal to 1 and y is also equal to 1, so in that case 1 plus 1 is greater than 1 minus 1, 0. So this is 2 greater than 0. So we are following the condition that x plus y is greater than 1. So yes. But the value of x and y are equal. So we can't say for sure that whether x is greater than y, because if x is equal to y, even though this condition is being satisfied that x plus y is greater than x minus y. So we will say that statement A is not sufficient to answer this question, right? Now, moving to statement 2. Statement 2 tells us that 3x is greater than 2y. Now if 3x is equal to 2y, so we will assume some values for this. Again we will be using this value x equal to 2 and y is equal to 1. So 3 into 2 becomes 6. 6 is greater than 2. So we will say that yes, x is greater than y, right? So yes. Now if we assume x equal to 1 and y equal to 1, in that case 3 multiplied by 1 and here it is 2 multiplied by 1. So obviously 3 is greater than 2. So this condition is being satisfied having values for x and y equal. So we can say that statement B is also not sufficient. So combining these, so this says that option D is also not sufficient. So if we combine these, there will be only these examples for this, and with the help of this we are not able to find whether x is discretely greater than y. So C is also not option for this. E is the right statement, that both the statements are still not sufficient to answer the question. In the figure above, AB, chord AB has length z centimeter, is tangent to the circle at A. So this is AB, which is tangent, and it has length AB is equal to z centimeters. Now, tangent to the circle at point, and chord BD has length y centimeter. So BD is equal to y centimeter, intersects the circle at point C. If BC is equal to x centimeter and z is equal to under root of xy. So we have been given, let's draw the figure first. So this is the figure. Here lies the point B and AB is the tangent. So AB is equal to 7 centimeter, and there is another line drawn from B, so CD, where BC is equal to x centimeter and this whole is equal to y centimeter. Okay. Now another thing we have been given is that z is equal to under root of x into y, and we need to find the value of x. Okay. So moving to statement 1. Statement 1 tells us that CD is equal to x centimeter. So this portion is also x. So this is what is given to us, that CD is equal to x centimeter. If CD is x centimeter, then we know BD is equal to BC plus CD, and BD is equal to y and BC is equal to x, and CD has been given us to x. So this implies y is equal to 2x centimeters, right? Now we have also been given that z is equal to under root of xy. So z will be equal to under root of x into y. Putting the value of x, we get x multiplied by 2x. So basically we get under root of 2 multiplied by x. So this is under root of 2x square. So under root of 2x. So z is equal to under root of 2x. But we are not able to find the value of x. So statement A is not sufficient to answer our question, right? Now Moving to statement 2. Statement 2 tells us that z is equal to 5 root 2. So statement 2 gives us z is equal to 5. We can't use any of the data from this. We just know that z is equal to under root of xy. This means that 5 root 2 is equal to under root of xy. Scaling both sides, we'll get 25 into 2, 50. So we get 50 is equal to xy, or xy is equal to 50. So still statement B is also not sufficient to give us the value of x. Right? Now moving to, so if A and B are not sufficient, so we can say that D is also not, that both statements alone are not sufficient to answer this question. Right? Now we will try with the statement C, which says that combining statements 1 and 2. Now, if we combine, we get that z is equal to root 2x. So z is equal to root 2 multiplied by x, right? And from statement 2 we get that z is equal to 5 root 2. So we can equate this. So root 2 into x is equal to 5 root 2. Cancelling root 2, we get the value of x equal to 5. So we can say that statement C for this question, statement C, that both statements combined can give us the value of x. So statement C is the right answer. Is the integer n a prime number? So we need to answer the question that n is an integer and we need to find whether this is a prime number, Pn. Moving to statement 2. Statement 1 tells us that n is greater than equal to 24 and less than equal to 28. So that means that n can have value 24, 25, 26, 27 and 28. Had it been there had been no equality sign, then we would have values 25, 26 and 27, that is greater than 24, less than 28. But now we have to include 24 and 28 also. Now, since it is an integer, n can only take these 5 values, and out of these we know that all these are composite numbers. So we can surely say that n is not a prime number. So for a statement to be true, we need to just answer the question that whether it is yes or not. So this is n is not a prime number. So we can say that statement A is sufficient to answer our question that n is not a prime number. Now moving to statement 2. Statement 2 says that n is not divisible by 2 or 3. So if n is not divisible by 2 or 3, then we can have the value for n equal to 7, and we can say that yes, it is a prime number because 7 is not divisible by 2 or 3. But hold on, if we take another value of n which is not divisible by 2 or 3, let us suppose n is equal to 25, which is not divisible by 2, not divisible by 3. But we can't say that n is a prime number because 25 has more factors. So it has 1, 25, 5. So this is a composite number. So we have yes as well as no situation from the statement 2. So we can say that statement B is not sufficient to answer our question. So the right option for this will be option number A. What is the average arithmetic mean annual salary of 6 employees of a tie company? So we need to find the average salary of 6 employees. Right? So that will be given by the sum of their salaries, salaries of 6 employees divided by 6. Right? Now with this we move to statement 1. Statement 1 tells us if the 6 annual salaries were ordered from least to the greatest, each annual salary would be $6,300 greater than the preceding annual salary. So we have been just given if they are arranged in an ascending order, then the lowest salary, let us suppose the lowest salary starts from 0. The next will be 6,300, next will be 12,600, next will be 18,900, next will be 25,200, last will be 31,500. Right? Now if we add this, or we can also have 6,300 as the first employee salary, and the next one will be 12,600 plus 18,900 plus 25,200 plus 31,500 plus 37,800. Or we can have another sequence starting with 12,600. Right? So this summation, the sum of all these salaries and sum of these all salaries will be different. The denominator will remain same. So we can't precisely give the value of average salary because we don't know from where the salary of the first employee or the salary of the last employee or salary of any of the single employee with this increment, we are not able to give the answer for this. Now moving to statement 2. Statement 2 tells us that the range of the annual salaries is 31,500. So see, in the first case the range of the salaries is 31,000. In the second also, if we subtract 37,800 minus 6,300, so again the range will be same. In this also the range will be same, but we don't know where to start, right? Whether the first employee salary is 6,300, 12,600, 18,900. So statement B is also, which, because this will change the sum of all salaries of all the employees. If we assume that the salary of the first employee is 6,300 and the last one will be 37,800, so statement B just gives us the range, that is the maximum an employee is earning and the minimum least salary and the difference between them. So that marks that our statement D is also not sufficient to answer this question. Now moving to statement C. When we combine statement 1 and 2, in the first case also we are getting the range as 31,500 with the first employee salary to be 0. And second case also, if you calculate, you will find that the range is 31,500. The employee's the least salary is 63,000. And then in the third case, so we can have numerous possibilities in which the salary of the second employee is greater than the first employee by 6,300 and the range is 31,500. Still we are not able to find the sum of the annual salaries of 6 employees. So statement C is also not sufficient. So for this, statement E is the right answer, that both the statements together are not sufficient to answer the question. If m is an integer greater than 1, so we have been given that m is an integer and it has a value greater than 1. Is m an even integer? So we need to find that is m is an even integer or not. Now with this information, we'll move to the statement 1. Statement 1 tells us that 32 is a factor of m. So that means that if 32 is a factor of m, right? So the factors of 32 are, all the factors of 32 will be the factor of m. So that means 1, 2, so 1 here 32, 2, 16, 4, 8. Okay? So all these will be also factors of m. Now let us get a scenario for this. Let us assume that m is having a value 64 and 32 is a factor of 64, right? And all the factors of 32 will be the factors of 64, right? So from this we can deduce that since it has a factor 2 also, so if that means that m is divisible by 2, so this means that m has to be an even integer, right? Now let us suppose if I write 65, but 32 is not a factor of 65. So in order to be a factor of 32, it has to be an even integer. So that means m is an even integer. So we can say that statement A is sufficient to answer the. Now moving to second. Second says that m is a factor of 32. So that means out of the factors of 32, m is a factor of. So these are the factors of 32. But here one condition has been given that m is greater than 1. So we can't have value this because this is the only odd factor of 32. So m can't have this value. This has been given in the main statement. All other factors you see that all are even. So we can precisely say that m is even with. So statement B is also sufficient to answer this question. And both the statements are individually sufficient, then we mark the option D. For this question, statement D, that both the options are sufficient to answer the question. Right? Thank you for today's lecture. If you want to build your concepts for any competitive exams which involve maths, you must read 8th, 9th, 10th NCERT books, which can be easily downloaded chapter-wise or whole book from the NCERT website. Plus, you must have some physical activity or 1 or 2 hours every day if you are seriously preparing for 1 to 2 hours every day. Bye bye, take care, thank you.